is Scientific American. Rockefeller University neuroscience named Hudspeth. And the photoreceptors there similarly have to convert mechanical vibrations there into electrical response. And the way this is done is there are so-called hair cells. These cells have little microscopic bristles, about 100 of them. And on the top of each cell, these bristles vibrate back and forth in response to sound. That sets up an electrical signal that then goes down a nerve fiber and into the brain. Hudspeth, the University of Wisconsin-Madison's Robert Fettiplace, and the Pasteur Institute's Christine Petit shared the 2018 Kavli Prize in Neuroscience for their work on the molecular and neural mechanisms of hearing. Hudspeth and Fettiplace both spoke April 9th at the National Academy of Sciences in Washington, D.C., at an event honoring 10 U.S. Nobel and Kavli Prize laureates. The evening was sponsored by the Kavli Prize and produced by Scientific American. More from Hudspeth. And the real question then is, what happens with these hair cells? As they degenerate, we lose them owing to loud sounds, we lose them owing to certain legitimate drugs, we lose them just with aging. And what can be done to repair them so that we can restore hair? Robert Fettiplace.
Well, I mean, there are two aspects to this. I mean, one is that, in fact, you could try and regrow them. Almost all hearing loss is due to death of the hair cells or lack of formation in the first place. The cells along the cochlea are all different. You've not got to generate a generic hair cell. You've actually got to generate one specific for each place. It has the specific properties which differ along the organ and will connect up to the nerve fibers. The problems that Robert has mentioned pertain to mammals, including ourselves. And the situation is very different with other four-legged animals, tetrapods. So in amphibians, in reptiles, including birds, this regeneration is going on all the time, same in fish. And in fact, you can take a chicken to, a Motley Crue concert or whatever, blast its ears, and they will quite nicely regenerate, even with frequency-specific hair cells. They will reconnect, and the animal will be able to hear normally again. I agree that there is an enormous challenge, and this is certainly something that won't happen overnight in ourselves. But I don't think it's a hopeless task, and I think basically what many people are trying to do is to decode the signals that are sent as these hair cells develop, and by doing so to recognize the signaling pathways that might be reactivated to recapitulate the original development and restore hair cells by that means.
Just don't take your chicken to a Marilyn Manson concert.
就是他刚才说，好像是某个神经元，然后他是抓一些空气中的信号跟那些声音到那里，然后他就有他的上下震动还是什么鬼的，然后传达给脑袋。对，然后后来我讲到说，我想想，我组织一下那个然后如果那个神经元如果它坏掉的话，就是要重新去制造它，但是好像只有鸡是可以就是重新制造，它坏掉之后可以重新制造，然后跟那个神经重新联系上，然后它就可以听到之类的。好，差不多这样。我要来看一下翻译。
换我讲，我的结论就是呢，完全听不懂。